One tree can start a forest. One bird can frame a goal. One candle can wipe out the darkness. I believe that this one program will be a fuel to drive a long path in your career. I'm Revati. We are immense pleasure to welcome you all with this beautiful morning with the new challenges and opportunities to take a participation in 3 days online training program on logical thinking and coding. I'm taking a honor to announce the toppers quiz and coding contest which was held on 26th June. Let me announce the quiz toppers first. First place goes to K. Rajendra, PEC, CSC Department. Second place goes to Pooja, IIT Rocket, IIT Rocket, RK Valley. Third place goes to Yoshita, CSC, Pratyusha Engineering College. Fourth place goes to Mr. Harish, PEC. Let me announce the coding toppers. First place goes to Harish and Abdul Prayas, CSC Department, Pratyusha Engineering College. Second place goes to Mr. Selvin Pal, SRM Institute of Technology, Chennai. Third place goes to Abhilash, Government College of Engineering, Tirunelveli. Thank you all. These are the toppers of the yesterday's session. By afternoon, we will announce the overall participants throughout this 3 days program, and we plan to award a merit certificate specially for them. Before leaving a forum, let me give a sharp note about today's session. Today morning, we are going to discuss about the topic dynamic programming. What do you mean by dynamic programming? Nowadays, most of them we are hearing about time complexity and space complexity. Yes, am I right? Yes. What do you mean by that time complexity? What do you mean by space complexity? All these things we are going to cross over by optimization solution. Exactly. Dynamic program is used to find the optimal solution for a given problem. What do you mean by optimal solution? Very simple. Optimal solution is nothing to find the smallest or largest path or something maximum or minimum value for a particular problem, like that. The similar way to find the optimal solution. Let me give a very fine example or 5 simple steps to approach the dynamic programming. First step, break down the complex problem into a smaller number of sub-problems. Second step, find the solution for sub-problem. Third step, store the result of sub-problem. Fourth step, reuse the result of sub-problem to compute the values of complex problem. Final step, altogether combine and produce the result. That's all. This is a very basic thing about dynamic programming. When I'm entering into the dynamic programming, what should be essential? What are the concepts I should go through on? What should be I learn first? Very simple. When I'm starting a dynamic programming, I may aware of function, recursion, arrays, and matrix. These are the very simple concepts are familiar to perform the dynamic programming. Let me give one more simple example about dynamic programming. Just you can take numbers 1. You can take a number 1 as a 5 times. Now, let me say 1 plus 1. What is the result? 2. Yeah, we may update it. 1 plus 1 plus 1. What is the answer? 3. So, first step, 1 plus 1, you need to store the result of 2 in a particular place. That's why I said in the first step, break down the problem into smaller sub-problems and store the sub-problem result. I said already, right? So 1 plus 1, we are storing as a result in a particular place. Next to 1 arriving into the place. Now 2 plus 1, 3. Again one more 1 arriving. So 3 plus 1, 4. Like that, it can goes on up to infinity time. We no need to compute from first to last again and again. If we are not using dynamic programming, what will happen? I need to use again 1 plus 1 plus 1 plus 1, etc. up to infinity time for each and every time of the computation. When I'm going for the dynamic programming, which is not required, because We are segregating the problem into subsequent problems. We are computing the result and storing those sub-problem result in a particular place. From there, we are taking a solution to produce a final result. Thank you all. Let me call upon Bashini to introduce the Sangeeta, who is a speaker of today. Thank you
Thank you,
all.
ma'am. Thank you so much for your wonderful explanation and making us what we are today. Thank you so much for once again, ma'am. Next, I call upon Miss Meghna from CSE third year to give our the welcome speech about our chief guest and our youngest chief guest also, Miss about our Sangeeta madam from Zoho. I call upon Miss Meghna.
Thank you, Vashni. Good morning, one and all. Once again, welcome you all for this mind training session. It's my pleasure inviting our resource person, Miss Sangeeta, along with our beloved staffs, HODs, and my dear friends. Before starting this session, I would like to share few of her achievements with you. Miss Sangeeta is a person currently working in Zoho and had many work experiences like she worked as a blockchain intern in Fixnix INC and a software trainer in FIIT and also used to take weekend classes in Nandavanam Trust. She also conducted many workshops at different colleges on Python, AWS Cloud Services, Android application development, and many more. She achieved elite certificates in NPTEL in programming data structures and algorithm using Python, introduction to C, and programming in Java. We are really pleasure inviting you, ma'am. Thank you.
I welcome Miss Sangeeta ma'am to start this session. A warm welcome to everyone today. Today, as ma'am told, we are going to see about dynamic programming. So, I think everyone could have got some basic idea of what is dynamic programming and how to solve it or how to approach it. So, it was a very clear explanation by ma'am. So, before going into dynamic programming, to solve dynamic programming problems, we need two basic concepts. Two essential concepts we need to understand to solve dynamic programming because everything is built about functions and recursions only in dynamic programming. So let me just tell about functions and recursion. So if you see functions, functions are like it is a reusable code. So you can write a single code and you can call it multiple number of times. So each and every time you don't want to process the whole steps to arrive the result. So for example, if you are going to design a mark sheet for some schools for calculating the marks of 500 students, and each student will be writing some 5 to 6 subjects. Okay, so if you want to do some system like that, then what you will do? Each and every time you won't write the code for adding, right? So you'll be clubbing it. What are the things we want to use it again and again? So we'll be defining some set of codes that we want to use again and again. So this set of codes will be defining as a function and we'll be using it whenever we need. We'll be using it. So just like that. So this is source. This is the function. We'll be just defining some codes and we'll be using it again and again. So that code is reusable each and every time we don't want to write that code for particular use case. Just simply we'll be calling for we have all come across scanf and printf in C. So this scanf and printf is a function only. You just imagine if this scanf and printf is not present, then what you will do? They are just C is a programming language, and they have been designed a compiler, and they have just designed a predefined functions for it, and that predefined functions only is making you to uh, code the thing very simply. Because if you see, if you take very simple program, like I'm just typing, so I'm just doing like in main, then I'm just printing some hello world program. Without this printer, what you will do? You should write how to do the set of programs. If you want to analyze more about this, you just go into this printf. You just see printf's library and printf function. Okay, just go inside stdio.h and you just go to printf function and you see how many lines of code is written for that printf, getting number of printing number of strings, and how it is going to print in screen and everything. So some set of lines of code will be written, but yeah, we are very easily using that printf function wherever we need. So this is the greatest advantage of function, and that is the main concept. That is the main thing what we want to know before going to dynamic programming. The next is recursion. Recursion is very simple if you understand the function concept. So what is recursion is, you just, it's a very tiny thing that separates it. Functions is, it is reusable code. We are just calling it somewhere else again and again. For example, from this main program, I'm calling printf again and again whenever I need. But I'm not calling printf inside printf function itself. Right. So if I declare some function like add, and if I call this function add itself again inside it, like I'm just having in A in B, then again I'm going to call add 2 comma 4, like that. If I call this again and again, this will be calling this itself. So this is said to be as recursion. So if you see, recursion and looping is will be the similar. Everyone will be getting confused with recursion and looping. So we'll be having the separate session in functions and recursion in afternoon session. But this is the basic idea of what I want to tell to you to just go into dynamic programming. So looping and recursion will be very similar, but looping will be occupying very much less memory space, but recursion will be occupying, it will be consuming some more memory space than looping. So we should decide when we want to go to looping and when we want to go to recursion. Every time we should not go to recursion, and every time we should not go to looping. If we want to go like tree traversal, then at that time we should go to recursion. And if you want to travel some integers, or if you want to travel some arrays, and in those kind of use cases, you should go to looping. So if you want to have a deep learning about it, I'll just you just follow this link. I'll be just telling this link. So if you have a study in that medium, you'll be understanding the much deeper. It will be like some 20 minutes reading, and it will be a very good approach, and it will be very easy to understand the difference between looping and recursion. Also, we'll be having the session about it fully, like functions, recursion, in afternoon. So I guess you could have understand some basic of functions and recursion, if not you have known before. So same way, functions will be having four type of functions. Like functions can be differentiated in many ways, but getting the input and displaying output, in that way we can define functions in four ways. So if you, here input and output matters, and simple, calling function and main function comes into picture. So if you match this, there will be a four conditions. If calling if calling function gets input, right, and gives output, so that will be as main function. So this everyone will be telling like without argument and without return type. So this is very very simple. So if you can't, everyone will be just confused with this function things like where what you want to use and the four types of differences. So it is very simple. You don't want to worry about it. If you want to give something, like assume a person. So assume a person A and person B. This A wants to get some work done from B. Okay. This A want to have some work done from B. B have to do some work for A. But A want to purchase something and give it to B. For example, if you see like if you want to give some writing things to your friend like assignments or record notes like that, if you want to give something to your friend, then that friend will be wanted to do to you. At that time, what you will do? There are two things. Input will be your input will be telling us stationaries, and output will be this is stationaries, and output will be telling us submission, right? You just take this simple example. So this I'm talking about this input and output. This is matched with stationary and submission, and this calling function, which is main function, right? This is main function, or it may be any function which calls the another function. Okay, not only from main function we can call any other function. We can call function which we define from any other function too. So this is the function from where we are calling the calling function. That called function will be calling. So this is matched with the person A, and called function is matched with person B. Okay. So input is stationary and output is submission. You just imagine what are the ways you will be doing it. So you will be buying stationery and giving to B, right? And you will be giving the submission. The first step is you will be buying the stationery. Always the processing, like the code will always have three things: input, process, and output, right? So this process will be always this friend. So process will be always this friend only. So he is only going to write. This process will be always that friend. So only we have been defined that person, or so only we have defined that function itself to process that code. So only we define that function. So the process will be them, but buying of stationery and buying of submitting the thing after the process is done, you will be giving the stationery to him, and after processing he will return that to this person, and you will be submitting, that is you will be printing the statement, the output, actual output. So this will be the one thing. This is mapped with this, right? Without argument and without return type. What is the thing is, you just take him, you are not passing anything to him, and you are not getting anything from him. He's not returning anything and he's not getting anything. Everything is being processed in main function itself, right? So with this only they have been defined this four thing. Now if you take each and everything, you will be understanding very easily. So the next thing will be, I'll just take this now. I think you could have understand now the process what we have been doing in functions. So now we will be taking this. We'll concentrate on this now. So the next thing will be, this is the first thing. The next thing will be with argument without return type. So now you can take from main function, you are passing something, but the function itself printing it also. Okay, so you are not getting anything written from the function to you. So in this case, what is the thing is you are buying stationaries and everything and you are giving to the friend, and the friend himself writing and he himself submitting to the respective thing. So in this case, he is not returning anything to you. So there is no return type. So with argument, he is having argument, he is getting something from you, but he is not returning anything. So this kind of thing is with argument and without return type. The third is the interchange of this. So without argument with return type. Right. So in this case, you will be understanding it very easily now at this point. So without argument means you are not going to give any stationaries, but you are going to get the return from him. So in function, you will not pass anything, but in return, it will be getting something. Return statement will be there. So then third will be, sorry, the fourth will be with argument and with return type. So this with syntax and some examples you'll be seeing in AppNote. But this is the very basic thing we should know in function. Recursion is also the same. Recursion will be calling always the same function again and again. So looping is like till the condition is satisfied, we'll be calling the loop again and again, and afterwards we'll be getting out of the loop. The same way recursion is also will be having on if condition, and if that if condition matches, then you'll be returning other thing, returning some uh, constant like 1 0, like that will be returning some constant, or to get out of the, you won't call that function again, right? Like this in recursion you won't call the function. If you want to end the recursion, then you will be doing like this, you won't call it, you'll be returning like 0 or 0 plus 1, like that you'll be returning. If you want to call that function again, then you'll be returning like add of 2 comma 3, like that you will be calling. So if you went into the functions, if you now started to see the program, it will be very easy for you, I guess. So these are the very basic things that we needed today. Now we'll get into dynamic programming, the actual thing. So if I again say that it is principle of optimality, divide and conquer problem, and sub problem results are stored, and that problem results will be using to get the actual problem, and backtracking, time complexity. So these will be always creating the mysteries again and again for you. So we'll be solving this problem, and you'll be understanding what these statements are meant to that problem. So it will be clear for you to understand that. Okay. Now we'll be taking a sample program. Now we'll take a sample program. Okay. I guess everyone will know about the Fibonacci. So Fibonacci is the series. It will be like this. So it continues. So Fibonacci is a series like this. If not, you have not seen this before, I'll just explain it. So it is the addition of the last two things. So initially it will be starting with 0, then 1. If you see this one, it will be the addition of this one. So if you take this one, it will be the addition of these two things, the before thing. And if you take this 2, then this will be the addition of this before thing. This 2 will be the addition of this 2, the 2 consecutive before it. So 1 plus 1 forms 2, then 2 plus 1 forms 3, then 3 plus 2 forms 5, 5 plus 3 forms 8. So this is the Fibonacci series itself. So if you want to find the nth term of this, So if I give like 5, so what is the nth term of 5? This is 0, 1, 2, 3, 4. Usually we'll be taking as this 1, 2, 3, 4, 5, 6. So if you assign like this, then this will be the nth term. Like this 5 points to this 3. So nth term, that is the fifth term, is 3. So usually how we will be approaching this particular problem. Just take a time and you just analyze how you will be using this. We have been solved this problem till this time. Okay. We'll solve this problem. So I'm taking an n to get the nth term and a variable to store the Fibonacci, the actual, the term, that the result of this. So we'll be taking as fib, or more clear we can take it as result. So you should get from the user the nth term. You are getting the nth terms. To the what term we should find the Fibonacci series. In what term we should get that value. So we are getting from user. Then I'm just having a result variable, and here we won't process it here. We'll be using a function. So before doing this, I'll write this function. So this function will be returning it to me. So it's going to process it, but the result will be returned to the main function. In main function only I'll be having the print statement. Here only I'll be having the printf statement. Right. So it should return to me. And I should pass. Here only I'm getting the scanf. Like here only I'm buying something. Here only I'm getting the thing. So I should pass this to that function. So we should declare like this. So here I'm returning it and I'm getting it. So this is like this function is with the argument and with return type. Right. Okay. So now what we should do here? We should have the variable to find the sum. Right. The previous two values is added up to find the result of the current question. So we need to have a variable for adding the sum. If it is 0, like if you see here, if it is in 0th position, if this n is 0, what you should do? We'll be returning 0. If it is n is 0, in n position we are having 0. So we'll be returning this. This is the error. We'll be having, put this away. If it is 0, then you will be returning 0. Right. Then if it is n, what you will do? If it is n is double equal to 1, what you will do? You will be returning that 1. Okay. The next case is if it is greater than 1. If it is greater than 1, what you will do? You should find the actual value for that. So here what you will do? You will be calling the previous portion, Fibonacci of n minus 1. That is, if n is 5, you will be calling Fibonacci of 4 plus Fibonacci of 3. So n minus 2. Then we'll be returning this sum. So, but if it is less than 0, what you'll do? This condition won't happen, but sometimes if the user give like -1 or -2 like that, first you can give the printf statement warning like you should not enter the any values in negatives. So you can give that caution and you can get the values. Even though if they gave, then you should handle that too, right? So if it is n is less than 0, this is not important here, but in designing any problem, you should always check for the negative cases, and you will be checking for one positive set of cases. This is the case and this will be happening, and so I'm just processing this input and I'm just giving output. You will be thinking like that. But you should think in other way. What if I gave the wrong input? So you can see in earlier days, we'll be having only one text form in website. So whoever gives a phone number in phone number place, whoever types some names or some anything, we won't have anything to validate it. We'll be getting it and we'll be storing. They have not think about it in very, very old days. But now we are not allowing it. Now we are having a checking for that, even in the worst case, even in the wrong case. So if in phone number means it should be a number, but if the text is string, what you want to do, then you should throw some error. So like that, each and every solving of problem, you should have this kind of knowledge and thinking. So this will be mainly used in like competitive challenges and like hacker rank, lead code like that. They will be having the test cases to mostly to get the negative test case only. So they won't give the positive test case mostly. They'll be giving negative test case, like how you are handling the negative situations, whether you are thinking the system on the whole. So this is the rough idea about it. So you should give this also. You can return 0 or you can print up like either way. You can return 0 like it is not a Fibonacci, so you're just returning 0, or you can print up like enter positive number, right? Or you can give like return 0. I think this will be clarifying you, but you'll be having some doubts in these statements for some, like why we have been given 0, 1, and greater than 1 with Fibonacci, like that. So I'll just explaining it to you. Okay. Here, if you see, so here I want to find the fifth question. What is that fifth question? This 3. So this 3. So what you will be calling from here? From the main function, what you will call? You will be calling that function with n, right? So we'll be understanding this concept and we'll be completing that program. Okay. So we'll be calling this f of n. So here, what is the f of n? Here f of n is 5. Okay. So if you understand the when I'm explaining, if you understand the concept and if you understand that something is going wrong here, then you can get the idea of dynamic programming. Like nothing will go wrong, but the thing is like we'll be doing some unwanted things here. So if you understand this, then it will be easy to going into dynamic programming. If not, I'll be just explaining it what it's getting wrong to. Okay. So if you want to compute this f of y as the logic what we wrote the logic like this, right? We wrote the logic like If it is, I'll take the positive thing alone here. If it is 0, then return 0. If it is 1, then return 1. If it is greater than 1, this is the logical part what we wrote in our code. If it is greater than 1, we should have like this function of n minus 1 plus function of n minus 2. Right. Initially n is sum is 0. So this is the thing what we wrote. So this thing will be getting into it now. Suitable for you. So it first comes inside this program f of 5. Here n is equal to 5. I'll put a memory box here. I'll put a memory box here. Now n is 5. So n is 5 is not double equal to 0. 5 is not double equal to 1. So it comes here. So here what it does, f 5 minus 1, f of 4. So it calls f of 4. So next 5 minus 2, 3. So it calls f of 3. Next, what we'll do, we'll analyze this. The next thing we should solve for this f of 4. So what we'll do, we should need the value for the before thing. What is the first thing before 4? That will be like we are understanding, we can put like this. So even for clear understanding, I'll put like this. So this will be the series. So if you want the fourth term, then you want the third term and second term. So that thing only we are just computing here, right? We want the third term and second term, the before, one before thing and the next before thing. So what we'll be getting here, f of 3 and f of 2. And here f of 2, and we need for f of 1. And for here we need f of 2, f of 1. So here we need f of the before thing, f of 1 and f of 0. The same way again. Here we need f of 1 and f of 0. Right. So this will be the thing. If you want the next before thing like f of 3 and 4, you should add to get the value of f of 5. The same thing for f of 4, 3 and 2, like that. You should get the values. So what we'll be doing here, at first time it comes into, so this is formed as this code, okay. So this is formed as this code. First, you should analyze this, what we are going to do. This only will be called for forming this as this. So if we go like here, another one, it will be coming like here again, it will be coming like f of 1 and f of 0. Sorry, I just missed it. Okay. So we are having the values for the leaf items only. So why we are processing till this time? We are having the values for only zeros and ones. Cause we have been, we can do like that only initially. So for f of 1, we know the value. For f of 1, what the value is like 1. So for f of 0, we know the value as 0. So we know the values for this leaf item very well. I think you can get this idea, whole picture about it. So we know the values for this. So from this only we can compute the other things. So this is just like a this is a bottom up approach only. From bottom only we are just getting the value for everything. From bottom we are just going into the leaf, right? So this will be like bottom up approach. So dynamic programming will also will be also bottom up approach only, but we'll get into the picture why we are just needed it. So here we are computing f of 1 is 1 and f of 0 is 0. Then we'll be going to f of 2. F of 2 is like the sum of this 1 and 0. So here we'll be computing this 1. Then this is 1. So f of 3 will be 1 plus 1. So you'll get like 2. Then we should go with this side. We have just finished the left of this f of 4 and we should go to right. So here we'll be having 1 and 0. So f of 2 is 1. So here f of 4, 2 plus 1, we are having 3 here. So the next thing. Here we'll be going 1 plus 0, we'll have 1 and 1 plus, here this is 1. So 1 plus 1, we'll be having 2. So here we'll be getting 5. So like this, we are just processing the thing. But you just notice here, each and every time we have been compiling for f of 2. Here, here. So the next, if we go with f of 3, here, it can be visible for you. Here, here. So each and every time we are just compiling it for it. So each and every time we are adding for it. So this is the problem which can be solved with dynamic programming. The main thing here is memory allocation. So we are having the values for 1 and 0 only, right? What if we store this values for 2, 3 and 4? If we store values for this separately, then we can use that values to get that. So now you can understand that what is this concept, what I told about it, that memory memorization and having the values for results for sub-problem. So that sub-problem results will be going to the main problem. So this is the overall concept why we are going with dynamic programming. So if you see here, we'll be having a memory. So we are having a memory and I'm just for initially storing and initializing with 5. So this is 0, this is 1, this is 2, this is 3 and this is 4. Okay, so it will go with 1, 2, 3, 4, 5. So here for 0th position, I'm just analyzing, I'm just giving it as 0. Next 1, next 1, next 2, next 3. Okay. If you see here, at this time, you should have got some doubt in this. So we are telling it as, I'll mark with it. So we are using it as 1, 2, 3, 4, and 5. Right. We are marking from 1. So user won't give any values from 0. But as a programmer, we'll be always starting with 0. Right. So here, the tiny error will be coming for everyone who starts to code first. Okay, so they will be getting the value in 1, like starting from 1, the user will be giving. So if you go with this Fibonacci series, 0, 1, 1, 2, 3, 4, 5, you will be seeing it as differently. You will be using it with this indexing. You will be indexing like 0, 1, 2, 3, 4, and 5. You will be indexing with this. But what the user will be giving is like this. He will be considering this like this only. 1, 2, 3, 4, and 5. So if you get the value from the user like fifth, and you return this fifth question as 5, then an error will be coming. So for just understanding, will be processed with this 5 only. We are just processed with this 5, right? But what you should do is like always, after getting it, while going into programming, we'll be seeing about it to get the thing like if we want to compute, if it is n equal to 5, when we get from user means we want to compute for 4. So this will be the thing. So you just don't confuse about it. Right, so here it will be very clearly you can see that. So I'm just getting some contradiction like here, like that you'll be getting into it, the picture, but we just don't confuse about it. In code, we'll be seeing it very clearly. Okay, so this 5 is 3 here now. Okay, so I'm just storing the value in an array. So I'm just getting some if user is giving like 5, then I'm just allocating 5 memory boxes like array, and I'm just going to store the value. I'm just going to compute and store. So here if you see, each and every time I'm going to store this value. So f of 1 is 1. So I'm just going and storing it. F of 0 is 0. So at initially I'll be storing like this. At initially I'll be giving like f of, so for f of 0, I'll be giving at 0. Right. For f of 1, I'll be giving as 1. So initially I'll be storing it. So initially I'll be storing it. Then I'll be computing for 2, and this 2 at this time itself I'll be coming and storing this 1 here. Then already I'm having f of 1. For computing f of 3, I won't compute again f of 2. So in our case, it will be calling again, but I won't compute it again. It will be always already stored here. So I'll be using that value, and I'll be taking it, and I'll be computing it. So this will be the difference between the normal thing and dynamic code. So now. Okay. If you get into this code, now you can understand it very clearly, I think. So now we are having this result. This result, what I should call a function, and I should pass this n there. Right. So n is of the thing. Now the user will be giving at 5. So what we want to do, we should give -1. Okay, now you can understand this. This Fibonacci n minus 1, that is Fibonacci of 4 is being called here. And this Fibonacci of 4, what it does is, this is the very normal approach without dynamic programming. Okay, the first thing what we explained explained in this tree. The first thing, we are computing for each and every values again and again. F of 2 is again and again computed. F of 3 is again and again computed. F of 1 is always taken. So this is the code for that. So we are getting 4 here. It is not less than. It is not equal to. It is not 1. So it comes here. Here we'll be calling f of 3 and f of 2. So this will be calling this function again, and it executes and the value will be stored here. Each and every time this code will be executed, like that tree will be traversed till it reaches here. Till it is returning 1, this will be travels. This will be just splitted into sub problems and it comes, right? So if we compute this, sorry, I'll just print this result. So for computing, I'm just using Control Shift F9 for compiling. You'll be using Control Shift F9 in code blocks, and for running, you'll be using Control the only F9. I'll share the output screen to you. So if I give like 5, it will be printing it 3. Okay, if I didn't use here like this, if I pass it n alone, means what it do is it gives in my way that in programming I'm starting with 0, so that will be returning 5. Okay, so here you can see this seconds. It comes like 5 seconds, right? So in this approach, it's coming like 5 seconds. This approach, what we are using here is this approach. We are computing each and everything again and again. F of 2 is again and again computed. F anywhere. So we'll now shift to dynamic approach. How you will go into dynamic approach of things. So in dynamic approach, you'll be storing the sub problems. So here also we are calculating sub problems, and that sub problems only forms the main problem. It is also a bottom up approach only. Everything problems anywhere here. So now we want to store it. So here everyone will get something. We are storing something. So whether the storage space will be getting increased or not, definitely it will be increased only. But here we are using recursion, right? So solving here will be using recursion. Recursion itself will be getting some more space than looping. So that and the space will be reduced. Also, the thing is, if you go to any industry or if you develop anything, any software or any architecture, if it is comes to space and time, if they will be all the developers will be choosing time only. So then space is not important. I'm not telling that space is not important. Space is also is a constraint. We should manage the space fill. But if we can't manage space, means we should what to tell, if it is a situation like choosing between space and time, it is a contradiction between space and time, means everyone will be choosing time. What's the reason is time is a thing that everyone needs now very in milliseconds or very urgently. If you just open a browser and if it is load for 2 seconds, then you'll be just closing it. You won't see it. If it is open within point some seconds, then you'll be feeling very better and you'll be using that website. Okay, if Amazon loads very largely, then you won't use it, but it will be at fraction of second it comes to life. So you'll be using it very easily. So that's the thing. Everyone now are going with time. Everyone needs it fastly. So the at the case when we want to choose between time and space, then yeah, definitely everyone will go with time. Because space also can be managed with anything. Like we can create space in cloud or we can create spaces. Space can also be managed. So we are having so much space, but we should manage space also. But in that case, we should go with time only. So the rough concept of this is just concentration on time. So we are just storing it. Everything will be storing it. The sub problems will be storing it. So later we can use this sub problems. The sub problem results can be used later, and we won't get the time constraint. So time will be reduced. Each and every time we won't go and you just see each and every time if you have some ready-made thing, we'll be preferring some ready-made foods only. If it is in ready-made, then you'll be going with that. So the process will be very easy and the time will be very easy. But if you want to do everything, even though you know like everything, if you want to do that manually each and every time, you won't go for it. Like the blueprint, if you have some blueprint kind of thing, each and every time you'll use that and you'll get the result out of it. If you're not having it, then you should process everything each and every time and you should get the result, and that processing time will be increased and processing cost will be increased. So in that case, storage is always a better option only. So here we are storing it and we are retrieving it. So how we can go with this method? So now we want to store it. Right now we want to store this and we want to get the result each and every time. So in this method we'll be eliminating this. Sorry, each and first time will be computing for 1 0, and for this, so this everything we won't compute, we'll be just taking from the memory. Right. I think my code is visible for you. So if you see here, the same set of things. I'm just calling a function. This function is again with return type and with arguments. So we are having arguments and we are having the return type. So we are just allocating a array for it. The array value I'm just giving as 50. So you'll be having if you get a doubt here, like I'm going to get the value as 5, then why I want to give as 50, then that memory space won't be a problem. So it will be a problem. We have a solution for it too. We'll be discussing it later. Initially I'll be giving it as 50, then I'm having some iteration. So if you see, if you come into the logic itself, you see what we told. For a of 0, I'm assigning it as 0. For a of 1, I'm assigning it as 1. The same thing what we did here. For 0 and 1, we are just assigning a static value. This 0 and 1, you will be giving it initially. So always it won't change. It may be n term can be of anything, but this 0 and 1 won't be changed. Right? So the next we should compute for this one. What this one value will be there? 0 plus 1 is 1. Right, so I'm storing it here. Then what I should go to this 2. So here this 2 is of 1 plus 1. The 2 precedence of this. So you'll be storing it like that till the value of n is reached. You should do this. Like here in our program, n is this 4. Okay, even though it will be like n minus 1, right? So here I'll be doing it. So here this is 0. This is index is 1, this index is 2. So I'm just starting the for loop from this 2. Cause for 0 and 1 already I gave 0th question and first question I gave. So I want to go with a of 2. So I'm just starting this with a of 2. Like I value I'm giving at 2. And if it is less than n, you all know the difference between less than and equal to, right? If it is less than means it will be taking the before element. If I give 5 here, so it will be taking 4. Okay, if it is less than or equal to, then it will be the loop will be travel till 5. Okay, I think everyone have know this basic concept, but if you are a starter, then this is the thing. If it is 2 is less than 2, then it returns false. So the loop will end. Okay, if we are giving us 2 is less than or equal to 2, then it returns true and it goes inside loop. So this is the basic idea. So we don't want to give n minus 1 here. Okay. So we are starting with 2. A of 2 will be A of 1 plus A of 0. Right. So this will be computed. So at initially we'll have some memory box here. Always when coding, you just put some memory box. You just put a memory box. Here in our case, we are having for A and assume I'm having A array and I'm having for I. So initially, I'm just putting like initially I'm just assigning A of 0 as 0. Right, A of 0 as 0 and A of 1 as 1. And this I value, I'm just again traversing. I'm just traversing with 2. So at initially, when I'm just starting the loop, I will be 2. So now we are computing for this position. A of I, A of 2. Right, A of 2 is now this position. So we want to compute for this position. Here, the previous thing, A of 1 plus A of 0. What is the thing? A of 0 is 0 and A of 1 is 1. So we'll be computing and storing this one here. Next, we are incrementing I value to 3. So 3 is I minus 1 and I minus 2. So this is 1 and 2. So here we are storing 2. So here next 1 plus 2, 3. I'm just storing this. And 5. I'm just storing this 3 plus 2 as 5. Right. Sorry, we just missed it. So if it is I equal to 4, it will be stopping here itself. If it is I equal to 4, I'm just computing this. When it comes to I equal to 5, then we are having a condition. Each and every time this condition will be checked, right? So if you take the for loop, the first time initialization will be done. So this is the first step. So green, this so this first time, this initialization will take place at first time. Then each and after initialization, it comes to this. After initialization, sorry, okay. So each and every time this will be happening, and after this happens, it comes to here, it checks, and it comes into the body. So after executing, it goes here. Okay, after initializing, it just goes here. So this will be this step. This step always gets written. So this step, and after incrementing, this goes to here and it checks for this condition and it comes here. So this loop will be executed the next time. So this initialization won't happen. First time it gets initialization and checks with condition and gets in. So after that it goes to this. So after that it just goes to this increment operator, and after incrementing it comes to this condition and it just comes in. So this will be the process, right? So if you go here, the same thing, if we get 4 here, if you get 4 here, 4 is less than 5. Yes, it's less than 5, so it comes in. Then after getting incremented, this n will be, now this I will be 5. So now 5 is less than 5, definitely not, right? So this 5, the next time this 5 is not less than 5, so it comes out of the loop. So till this it will be processed for you. So this is what we needed actually. So this value, so in user point of view, this is the fifth value, right? This is the fifth value, 0, 1, 2, 3, 4, 5. So this will be written now. This 3 will be written now. This computation is very, very, very simple, right? At that time, you should compute for each and everything. It will be having that much computation. But here, we are just computing it for only, you say like 1, 2, 3 times only. We are just computing for 3 times. Like n minus 2 terms only, we are just computing. If n is 8, then n minus 2. Already, because already 0 and 1 is assigned. So, it will be very, very, very simple process. But in that before approach, we'll be computing each and every time for many times. Each and every sub problem will be computed each and every time. So that will be increasing the time. Right. So this is the difference why we are going into dynamic approach. So dynamic approach is not the thing of coding. It is not a concept. It is the way how we will be responding to the situation. So if I'm telling just write the Fibonacci series, you'll be doing this one. You will be computing the before element and you'll store. Like you see what you'll do. You'll if I'm telling to write for Fibonacci series, what you'll do, you just write 0 and you'll use this 0 to write 1. Next, you predefine, you know the 0 and 1. Then you'll use the 0 and 1 to use, again you should write 1. Then you'll use this 1 and 1 to write 2. You won't go anywhere to get this one again, to get this one again. And to get the next element, you'll be using this 2 and this one only to add. Okay, you won't go and compute this again and again. You won't come from starting to 1 plus 1 2, so 2 plus 1 3, so I should write 3 there. You won't do like that. You will be just adding this 3 plus 2. So 3 plus 2 you will be doing at 5. You won't go come with starting 0 1 1 plus 1 2 2 plus 1 3 3 plus 2 5, like that you won't go, right? So if you think deeply how you will be solving the problem, you can easily understand, like from starting we have been trained to solve the problem in this way only. So our time is reduced. If someone will be starting from first each and every time, his time will be waste and he won't give the answer fastly, right? So we have been trained to do this only. We have been analytical and dynamically. We have been trained and we have been very well prepared to solve the problem. But we are not realizing. We should realize it and we should make the system. The whole thing is what here in this world. What we are doing is we are just whatever we know. We are just going to tell to teach to computer. So computer will be using again and again. So we don't want to use it. We don't want to compute that again and again. The main thing is that only. If you go anywhere, whatever things we are using, we want to automate it. We want to make the computer to learn that, and the computer should do it the same exact way what we are doing. So how to say, like we'll be doing it in 5 seconds. Mean we should want to train that computer to do it in 2 seconds or 3 seconds, right? So even now their research has been going like milliseconds. Also, they have been researching to do some task. So what is that whole matter is just thinking and making the code more efficient to solve it very, very, very less time. Okay, so that is the thing of dynamic programming. So whatever the program you are doing till now, you just think like how I can do it in dynamically, how I can store. When you can go with dynamic problem, like you'll be having a doubt. Then in which problem I can go with dynamic? If you think some problem will be having sets of subsets of problems, like it will be just traveled with down and down, down. It will be going to each and many things. It will be going down and down. So each and everything will be very similar. Each and every now, if you take our problem, everything is very similar. Computation of this is always the same. Computation. So this thing is always the same. So this sum of f of n minus 1 of f n minus 2 is always same. We are not going to change it. Each and every time you are solving this, then you should think how I can reduce this computation. How I can reduce this computation? If you think like that, then you can easily solve it. So I think now you'll be having a basic idea of what is dynamic programming and how we are going to solve it, like when we want to do. If you now go with these points, what I started before, you will be getting a clear picture out of it, I guess, right? If you now see this principle of optimality, what is set as principle of optimality means some problems will be having very we can get the very minimal amount of solution, very minimal amount of result, or we can get the maximum amount of result, right? So at that time it will be like optimality. So that problem we can be solved with dynamic programming. So we should get something the maximum result. We should get the optimality. Then it is like divide and conquer problem. It is similar to divide and conquer problem only, right? We are just dividing the problem individually. So next, results of the smaller problems are stored. If you see, then you just see this also. Results of smaller problem is stored and backtracking is used. Time complexity is being converted from exponential to polynomial, right? If you see here, this small problems is being stored here. This results of small problem is stored in array. So this results of small problem is stored in array, and we are using that array, we are using this array to get the value, right? So it is also a backtracking approach only. Then if you come to time complexity, so we didn't run this program, right? If you run, you can understand. So here we are just using and we are just saving it and we are just getting it from the array and we are just giving the answer. If you see here, I'm just giving the n minus 1 result. Like till 4 only we are stored, right? Till 4 only from our point of view, array starts with 0 and fifth position means it is actually the fourth index. So I'm just giving n minus 1 as a return. So it will be printing it. So I'm just compiling it and I'll run it. If you see, I'm just giving 5. You see, there we got 5 seconds, 6 seconds. So now we are getting only 2 seconds. Right. So this is the thing what we are just doing here. Even though, so I think overall, if I just get, you'll be understanding the overall picture. First, we used some approach to solve this nth problem of Fibonacci series. There we are just processing for each and every element, and we are just storing the answer there. Sorry, we are just getting the answer each and every time. We are just computing, and we are just we are just moving up in a tree. We are just moving the up in tree, and we are just getting the actual nth, and we are just printing it. But in dynamic approach, each and every time we are storing it, and we are not computing it again. That f of 2 is not computed again. That 2 value, the Fibonacci second portion is not computed again. It is stored already, so we are just taking from there. So this is the way of dynamic approach. So this is for time, and we do have for storage. So memory allocation, dynamic memory allocation. This is dynamic programming approach. How you are going to solve some program in dynamically. So we have another thing like dynamic memory allocation. So we'll be having 4 concepts for it. It's also a very simple concept. It is malloc, calloc, free, realloc. Okay. So what this malloc will do is, till this time you will be assigning the size of an array statically. You will be initially giving that array value. You won't have an option. So here I'm just giving 5 only. I have said before said here n is 5 only. Then what happens for remaining 45 position? Memory will be allocated for that too, right? So what will be happening? So if you see here, this memory will be allocated like this. Even though we have 5, it will be allocated like this. This space is not at all needed for us, right? So what we are going to do is, So we want to have some dynamic way of allocating memory. So we want to have some dynamic memory allocation ways. So this will give a solution for you. So this MLOp, what it does is it gets the n value from the user. We are going to get the n term from the user. So till that only we are going to allocate this space, not more than that. Okay. In runtime, we are going to allocate the space itself. So I'll tell the difference between mloc and calloc. What the mloc will be doing is very simple. If you give n equal to 5, what it does is it will be, if like you see, if it is integer, what will be the value for it? Integer value is 4 bytes, right? 4. So 4 asterisk 5, 20, right? So yeah, 20 bytes will be allocated like this, a block, and garbage value will be stored here. This is for malloc. This is for malloc. If you go with calloc, here what it does is, as of an array initialization, it gives, it separates 5 and it will stores 0 in every position. So this is the difference between malloc and calloc. Then what this realloc will do is, if you give realloc, then this memory will be deleted. So you will be having some point, as yesterday we discussed, we'll be having some point. We'll be having that is that variable will not be used anywhere else. That use of the variable is over. But how you can deallocate the memory for that? So in C you will be using this realloc. So that memory will be just deleted. It will be deleted from the memory. That space will be deleted. So then what? Realloc is, it will be deleting and it will be creating, modifying it. It will be deleted. Sorry, I just mistakenly said about free. It's actually realloc means it will be deleting it, but it will be reallocating the space. If I give malloc equal to 5, I'm just having f 5 and I'm just giving malloc means it will be creating as 5 means. If I want to change the value, if I want to change is the very best and effective way to just go with lead code challenge and create a git repo and just post this challenges there. So it will be like open source, be contributing to that also, and also you can solve the problems. So even in hacker rank, you'll be having dynamic programming questions. So we just first solve those problems, and each and every time when using an application, when it is getting a slow or some you're getting an error, you just think as a developer purpose. So it is a very effective way to become a best coder. So in that way you can analyze many real time things, and you can relate with many real time things, and you can solve many more problems that we are around you. So I think this will be the thing for you will be understanding it clearly. So just go with W3 School, Java T Point, and HackerRank for basics, and you go with code, lead code challenges, and code forces to get into it very deeply. So thank you all. Just practice what I told. Just allocate the memory and just practice this last problem what I discussed too.
Thank you, Akka. Thank you so much for your marvelous session. Definitely, your ideas and approach will help us to crack the logical thinking and coding. Once again, thank you so much for your generous time which you have spent it with us. There are certain instructions to be followed by the students. The quiz link and the feedback link has been posted only in the morning session, not the afternoon session. Now it has been posted in the chat box. You can verify over there. And the overall topics for the quiz and the hacker rank will be announced at the afternoon session by our ma'am, head of the ma'am. No issues with that. And merit certificate for overall toppers and the participation certificates for the students that will be sent through your email within 2 days. That's all. These are the instructions to be followed by the students. And at last, we should be thankful for each and everyone who gives the chances work to us. I call upon Mr. Nagaraj from EC EEE department to give away the vote of thanks.
Thank you, Rashini. Good morning to one of our present this webinar. I'm taking it as my honor to present the vote of thanks in front of you all. On behalf of Pratisha Engineering College, I extend my hearty thanks to our resource person, Ms. Sangeeta ma'am. We always loved your detailed step-by-step explanation, ma'am. Today, because of you, we have learned more and more about time management and how to dynamically handle it. Even though we are able to make code, the major problem that is faced with us is making it as a time efficient one. Today, you have helped us with it by your explanation, ma'am. I thank you from my bottom of my heart, ma'am. My friends, thank you for joining us in this webinar and making it as a huge success. I hope you all are always eager in learning. So I request you to like this video and subscribe and turn on the notification to our channel, so you will be able to know whenever we are posting a video for you.